Yo guys, what's up? It's Panda Power here for a new video. Today I would like to explain you some DevOps concepts and also give you some great examples, tools, and processes that you can apply in your new quest to become full DevOps. So let's start. What is DevOps first? Okay, it's a good news for you guys because I will start directly by answering the question that is in the title of this video. Hooray, you can say. So, as a global definition, DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity, evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. This speed enables organizations to better serve their customers and compete more effectively in the market. What is the importance of DevOps in the development cycle? Here is the typical representation of the DevOps approach, representing the development cycle with planning, coding, building, and testing, as you can see on the left side. And then comes the ops part, where we deploy, operate, and monitor the different systems running the application on the right side. Unfortunately, in the past, and even in some current companies, the development teams and ops teams are totally separated and in different silos. So the development has always the same challenges. Basically, they want to deliver as fast as possible their software with last features to please their customers, and they have to respect a tiny budget at the same time. To achieve these goals, they have sometimes to cut corners. On the other side, the upside, they want something that is stable, reliable, because they are operating an application and are usually directly responsible for any production issues. From this paradox came a new idea of putting together these two teams, so what we call a DevOps team, and give them a totally new objective. Have a shorter development cycle to be able to deliver features into production at a faster pace and with a higher level of quality. This new concept is way more closer to the business objectives because we want to deliver as much as possible value to the business without less downtime and or defects. Third point, what DevOps is not. We're often doing a shortcut between continuous integration and continuous deployment, also known as CI/CD. But DevOps is not only that. CI/CD is only a consequence of the DevOps culture, I will say. It's the same thing for the collection of tools we can find on the market today. We can't say it's DevOps because DevOps is more than that. We can see DevOps as an ecosystem where we'll have dev teams and ops teams working and talking together with the goal again to deliver features into production at a faster pace and with a higher level of quality. Something that is always forgotten is that the practices and processes are also part of this ecosystem that represents DevOps. So, to sum up, DevOps philosophy is to get isolated teams working and talking together with some processes in place and some tools and specific environment to deliver working features in production. So this is what DevOps is. We'll see it also later that DevOps is bringing some concept of automation that we can sum up by saying that we encapsulate the knowledge into scripts and automated tools to support the development and the operational team merge together to achieve the delivery into production. Fourth point, some tools we can find on the market to achieve each category of the DevOps. So here you have a schema. Something we can see here is that we have different tools to cover the different phases of the DevOps cycle. Also to mention that now we have non-functional requirements that come into play that we didn't have before in the traditional development cycle. Because now we bring a lot of new tools to build easily our app, to monitor it closely, to test it easily. So it brings a lot of non-functional requirements that we should take into account when we plan or manage a project. But at the same time, it's bringing a richer environment. If we look at the landscape, we can see that everything is not there, of course, but it's giving a good idea on what tools and techniques we can use to define the DevOps pipeline. If we look closer at the different tools that we can see there, you're probably already using a bunch of tools part on this list. Not doing officially DevOps doesn't mean you're not using anything that is part of the DevOps. And you might be closer to the DevOps approach that you think definitely. Maybe you're using already some spread tools like Trello, Jira, Slack, or Teams, maybe also Git or Jenkins. Also, don't be afraid about the middle column that is for the test phase. You can see a lot of tools there, and it's just because test tools are usually made to simulate the human being or specific system behaviors, and there are a lot of different technologies to cover. Just an example, you won't test the same way systems communicating in RESTful API and others communicating in SOAP technology. Just for that, we need two different tools to tackle each of them. Fifth point, a new type of job is emerging. I'm pretty sure you saw some new job description on websites like LinkedIn or Monster or something like DevOps needed, with some different requirements, not necessarily the same from one job description to another. It's because no one has any clue of what a DevOps engineer is supposed to do. What is sure is that a DevOps engineer is not there to do development. He's not also there to do any operational activities. That person is there to support development and operations. So basically, he knows the tools, he knows the processes and concepts that are surrounding the development and ops team that are now a unique team, if you remember well what I told you before, and support them by helping them using the tools, processes, and environment in place, but also in constantly improving them. Sixth point, unfortunate deployment to production or when shit happens. Okay, let's say someone pushed code to production in a small one-line change. It nicely flows through the deployment and integration pipeline. A few minutes after deployment to production, alerts start firing. That one-line change must have had unforeseen side effects. The on-call engineer intervenes and rolls back the deployment. Analytics look normal again. The team decided to employ industry standard tooling for continuous delivery and continuous integration. The engineer did the same thing by writing tests and running them before pushing the code. Still, the alerts went off. Thankfully, the teams use good monitoring and alarming tools like Grafana or Prometheus to aggregate metrics and trigger alarms through PagerDuty. They also have Elasticsearch and Kibana for log analysis. The issue is that the classic monitoring and alarming tools don't tell you what broke exactly. The engineer might spend a lot of time trying to figure out what broke. Latency was up, but the spikes were inconsistent, going up and down randomly. There is no correlation between the number of requests and the latency spikes. There are no other fault or error alerts. Staring at the dashboard, scrolling through logs, and looking at code takes hours. Eventually, the engineer identifies the problem. The fix takes 5 minutes to write, Safari found browsers were triggering a weird behavior in your web app. Pushing to production is scary. A failed deployment can be a traumatic experience, and can lead to a culture of fear with fewer releases. In a DevOps culture, the unique team should sit all together and talk about how to improve this kind of situation. And because you're nice, I will bring you a portion of the solution to this kind of issue that I'm sure a lot of you guys already experimented in your different past experiences. So the seventh point is crash reporting to improve observability. With a great crash reporting tool, you can spend all your time coding and actually fix the bugs, rather than going through millions of lines of logs to try to figure out what happened. Crash reporting is a way to automatically collect, analyze, and triage stack traces of the software you write. You want your tool to be simple to use and reusable for any language and on any platform, front end or back end, mobile or web or VR. It should integrate directly into your development and debugging workflows. You can't test everything. There are always edge cases you miss. In contrast, you figuring out all the way our system works by testing it. We had metrics, monitoring, dashboarding, alarming, log analysis, and analytics in order to figure out how it is actually behaving. Monitoring allows us to figure out how the APIs are doing, but monitoring is dumb in the sense that it's just data that has no context and no value by itself. You are just spewing off numbers to look at. You add alarms to add some meaning to them, but the alarm thresholds you create again just warn you when something is wrong. You don't usually know exactly what's causing the problem. Observability is the domain of adding a layer of understanding so you can tell how your system is behaving and how it is interacting with other parts of the system. Monitoring helps you understand how your system is behaving, but you want more. You want to understand interactions and links between data. You want to figure out that the service A is crashing because the service B is not behaving like expected. You want to be able to tell that latency in your API is due to just a specific super user couple who has 20 million items on their wedding registry. You want to be able to tell that Internet Explorer 9 is the only browser that is causing all these failures in your system. In order to build observability, we need to build tooling that is smarter than monitoring. We still need monitoring, by the way. It is foundational, but not enough by itself. We need crash reporting, performance monitoring, and insights about user interactions. When your app crashes, or you see failures, or you see faults, you want to figure out what went wrong in literally seconds. You want all of this happen fast and in real time. Crash reporting is the tool that can do just that for you. Raygun is a tool that can help uncover failures in many different scenarios by doing rolling deployment failure, recurring failures, dependencies that fail, low frequency failures, filtering out the non failures, expert mode performance, monitoring, and real user tracking. And it's what is concluding this video. Hope you enjoyed, guys. Before leaving, please take some time to subscribe to the channel and leave a comment or two. And especially if you have questions, don't hesitate. It will be a pleasure for me to answer them. Thank you. Bye bye.